and eventually winding it onto a large bobbin. What was once a rod 10 millimeters in diameter is now down to just 2 millimeters, the width of about a dozen human hairs. They load the bobbin into what's called a stranding machine. They cold weld the end of one bobbin to another, guaranteeing an uninterrupted flow once they start up the machine. At high speed, the stranding machine twists 7 wires together, forming an electrical conductor, also called a bare conductor. This is a low-voltage conductor, under 1,000 volts, the kind you find in the cables that run electricity from the hydro pole to your home. Bare conductors need to be insulated so people handling them won't get an electric shock. A plastic extrusion machine coats the conductor with polyethylene or PVC. This insulates the conductor. This is what the polyethylene looks like in its raw form. As the conductor exits the machine with its new insulation, a precision laser gauges the diameter to make sure the insulation is uniform and the right dimensions. The extrusion process has heated up the conductor, so it has to be cooled down with water. Sometimes 2 or more conductors are twisted together. When that's the case, a printing machine applies a white stripe to identify which is which. The client who's ordered the conductors specifies the colors of insulation. It chooses them based on how it wants to color code its electrical wiring. Several conductors are often grouped together to form a cable. The plant performs a voltage test, immersing the cables in water to make sure they don't short circuit. These medium voltage cables can carry from 1,000 to 46,000 volts of electricity. They're the type used for underground hydro lines. They're insulated the same way low-voltage cables are. The plant prints the date of manufacture, the voltage, and any other information the client has requested. The cable then goes onto a reel to be tested before it's shipped out to its destination. In the middle of the cable, surrounded by copper grounding wires and a host of other components, is the heart of the electrical cable, the bare conductor. Many machine parts are simply stamped or machined out of solid metal, but parts with complex shapes or thin walls can't be made that way. They have to be cast, using a technique called lost wax process casting. It takes anywhere from a week to a month to manufacture a cast metal part, depending on its complexity. The first step is to inject wax into an aluminum die, which is essentially a mold whose cavity is in the shape of the part. This creates a wax model slightly larger than the finished part will be. They'll use this wax model to make a mold out of a ceramic material. That also has to be larger than the finished part because metal shrinks as it cools. Once the wax model is ready, they stamp on a code to tell the foundry workers what type of metal to use to cast the part. Next, using a hot iron, they attach wax components to create what's called a metal delivery system, channels that will funnel the molten metal into the mold's cavity. Next, they dip this wax assembly into a ceramic solution called slurry. They do this by hand to prevent imperfections that would cause defects in the casting. To strengthen the slurry, they coat it in a fine zirconium sand, then let it dry. A robot then keeps repeating the process with coarser sand until the ceramic shell surrounding the wax assembly is about 7 millimeters thick. This takes 5 days. Now the ceramic-covered wax assembly is ready for what they call the de-wax. Workers place it in a hot steam chamber called an autoclave for 5 to 10 minutes. This melts the wax right out of the shell, creating a ceramic mold whose cavity is in the shape of the part. Once the mold has dried out, workers can begin to cast the part. First, they put the cold mold into an oven and heat it up for 2 to 3 hours. This prevents the mold from cracking from the shock of coming into contact with molten metal that's a piping 1200 degrees Celsius. They pour the metal into the mold's cavity, then let it cool and harden at room temperature. That takes 2 hours for aluminum, 4 to 5 hours for steel. Once the metal has cooled and solidified, they break off the ceramic mold using a vibrating hammer. This takes about 5 minutes. They saw off the metal delivery system